Welcome to this video. In this video, we want to learn how we calculate the heat of formation when we have been given the bond energies. Do not forget to subscribe to our YouTube channel, that is Zuluba Consultants, and the Facebook page for this and more videos. The question that we have reads, calculate the heat of formation of hydrogen using the bond energies below. So we have been given these bond energies, then they have asked us to calculate the heat of formation. So in some cases, they might not use heat of formation, but they can use the energy of formation. The steps you use is the same. The first step that we want to learn in this video is look at the equation that you have been given. If you have not been given the equation, are you able to come up with that equation? If you come up with that equation, check if the equation is balanced. So the first step is checking if the equation is balanced. So our equation here has nitrogen reacting with hydrogen to form hydrogen. And in our case here, the equation that we have been provided is already balanced. After balancing the equation, the next thing you need to do is to come up with the Lewis structures of the compounds or molecules in the equation. In this case, we have hydrogen, and in this video, we are not going to explain to you how to come up with these Lewis structures. But we have produced a lot of videos. You can scroll under Zuluba Consultants channel and you will find those videos. So in this video, we are simply going to illustrate to you how we have managed to come up with the Lewis structures. For the first one, we have nitrogen there. So the Lewis structure for this will be nitrogen bonding with 3 bonds and another nitrogen there. We have hydrogen. Hydrogen, we have 2 of them because of these 2 which is here. So 2 hydrogens are bonding there. Then for hydrogen, we have nitrogen bonding with another nitrogen and 4 hydrogens attached to them. So if you manage to write these Lewis structures, then you have managed to perform the second step when you want to calculate the heat of formation using bond energies. The third step is for us to come up with the summation of the energy used to break down the bonds and the energy used to make the bonds. So the difference between the energy used to break down the bonds and the energy used to make the bonds, that's what we call the heat of formation. So let's look at what we have here. We can divide these into 2. We have reactants here and products. So on the reactants, we want to come up with the summation of the energy that was used to break down these bonds, so that at the end we come and look at the summation of the energy that was used to form these bonds. So when you look at the first one, we have nitrogen. So on the table or on the figures below, we have the energy that is needed to break down these 3 bonds. So for nitrogen, we have 946 as the energy needed to break these bonds. Then we come to hydrogen. We have 2 molecules of hydrogen. So one of the bonds, we need 436 to break this bond. So we'll say 436. Then we need to come up with the sum of this. When we look at the bond formation, as we are analyzing the bond formation, we need to look at what types of bonds are here. So the first bond that you can notice is the nitrogen to nitrogen bond. So nitrogen to nitrogen bond, how many bonds do we have that are nitrogen to nitrogen bonds? We have 1. So we are saying we need also to have 159 kilojoules per mole for us to form this bond. Thereafter, we have nitrogen to hydrogen bond. Now, nitrogen to hydrogen bonds, how many bonds do we have? We have this one, 1, we have this one, 2, this one, 3, and this one, 4. So we have 4 bonds of nitrogen to hydrogen. Now, nitrogen to hydrogen, what's the energy that is required? It is 389 kilojoules per mole. So if you do this, then you have analyzed the energy needed for you to break the bonds and the energy needed for you to form the bonds. Let's start with the bond breaking. So we are saying bond breaking. What is the sum of the energy involved to break the bonds? So the sum there will be 946 plus, open bracket, 2 multiplied by 436, close bracket. The answer we are getting there is 1,818 kilojoules per mole. Then we look at the bond making. What is the amount involved there for bond making? We have 159 plus 4 multiplied by 389. We are getting the answer of 1,715 kilojoules per mole. The difference between the bond breaking and the bond making gives us the heat of formation, or in other cases, the energy of formation. So the energy of formation then will be equal to 1,818 minus 1,715. So heat of formation will be equal to, when we now use the calculator to solve this, we are saying 1,818 minus 1,715. It gives us 103. So 103 kilojoules per mole becomes the energy that is needed to form hydrazine.